Alright, so when you're reflecting, you're going to create congruent images, which means that they're the same shape and size. The only thing that's going to change is they're going to be a mirror image. So if I'm reflecting over the y-axis, what it means is that I am going to go across the y-axis the same distance away from the y-axis on the other side. So if you look, point A is 1 to the right of the y-axis, so point A prime is going to be 1 to the left. Alright, so just remember these little marks right here are prime symbols. It's telling me that that is the end image, okay? So technically this blue figure right here is the pre-image, it's what I start with. The image is what I end with. Alright, I can find the other points by doing the same thing. It helps if I write the right point, sorry. Because we're going to talk about what happens to the points in just a second as well. So if you look at point B, it is to the right of the y-axis by 2, so B prime will be 2 to the left. Alright, and then C is actually 5 to the right, so it'll be 5 to the left. And I'll get this point right here. So if you look, okay, first thing, making sure that you're labeling your axes, not axes, vertex, sorry. So your vertex needs to be labeled so that you can make sure that the right point lines up with its pre-image. So if we look at the pre-image points and the image points, you'll notice that the numbers themselves have not changed. Okay, like it's still a 1 and then a 4. Okay, but if you look at the points, you'll see that the x value changed sign. Okay, so what you're saying is if you're reflecting over the x-axis, it's kind of like a rule here. So if I start with the point x and y, if I reflect over the y stays the same and the x changes to the opposite. Okay, so if they're asking you for a rule, this is the rule for reflecting over y. The y stays the same, so whatever you are reflecting over stays the same. And then whatever the other piece, the part you're not reflecting over, changes to the opposite. Okay, so just be careful. Again, the basic of reflection is the same distance away from whatever line, but on the opposite side. Okay, so when we look at ones that are a little more challenging, looking at like one like this, you'll see that the y-axis is actually like in the figure. That doesn't actually make it that much worse, okay? So when we're looking to actually reflect this, there's two ways we can do it. We can either use the rule. So if I start with a point, since I'm going over the y, the x will change and the y will stay the same. Okay, so I can do that. So if I use that, point A, the opposite of this x value would be a positive 3, and then the y stays the same. So I'll get a point right here. Okay, now it works the same way if I just count from my axis. So if I counted from my axis, A is 3 to the left, so A prime has to be 3 to the right. Okay, so that might be another way to think about it that might be helpful. So I can do the same thing with B, so it's 1 to the right of the axis, so it's 1 to the left for B prime. And then C is 1 to the right of the axis, so C prime will be 1 to the left. Alright, and then I'm just going to try my best to draw all this because I can't see my dots. And you'll be using the Desmos tools, so that'll be easier to draw straight lines and all that. So the thing is that as you're looking at these, there are two ways to do these problems. You can either use the rule, so whatever you're reflecting over, that part stays the same, and then the other part will change to the opposite sign. Okay, the other way is just to literally count. Okay, so just remember the basics of reflection is the same distance, but on the in the opposite direction. And make sure when you're reflecting that whatever your axis is the one that should be in between your two pictures. Okay, now this one's weird because it's overlapping, but if I look at the one we just did, you'll see that the y-axis is the line between the two pictures. Okay, that should be the case if it's not overlapping the line.